Welcome to the Tellabs Optical LAN instructional video using LLDP with VoIP phones. The purpose of this video is to give guidance and instruction on the use of the link layer discovery protocol when using voice over IP phones. The topics covered in this video will be an introduction to LLDP and its application to voice over IP, configuring network policy TLV to support voice VLAN, and an explanation of some common VoIP phone issues when using LLDP. Many IP phones have been actively used and are known to work well with the Tellabs Optical LAN system. A list of these phones can be found in the engineering application note LLDP with VoIP phones. In general, most devices are transparent, but some phones are not compliant to the standards and require some additional configuration for proper operation. Any phone should be able to work well with the system. However, some phones may require slightly different configuration for proper operation. The Link Layer Discovery Protocol, or LLDP, is a vendor-neutral link layer protocol in the Internet Protocol Suite, used by network devices for advertising their identity, capabilities, and neighbors on an IEEE 802 local area network. Media Endpoint Discovery is an extension of the LLDP protocol and supports auto-discovery of LAN policies such as VLAN, Layer 2 P-bit marking, and DSCP settings, device location discovery for E911, extended management of PoE endpoints, and inventory management to find the manufacturer, software and hardware version, and serial or asset number. For phones that support the configuration of voice VLAN via LLDP, the Tellabs OLAN system can be configured to pass this information on to the phone. This is done with the network policy encoded as a type length value, or TLV, in the LLDP messages. Configuring the system to send the network policy TLV allows the phone during its boot cycle to configure itself automatically with the voice VLAN. There are several steps to configuring the LLDP network policy on the system. First, the transmit interval for LLDP should be set to a 60-second interval. This dialog is reached by clicking on the NE and selecting Protocol Link Layer Discovery Configuration tab. Adjust the transmit interval if needed. Next, ensure that the LLDP profile is configured. To do this, go to the Profiles, select the LLDP tab, and create a new LLDP profile. Make sure that LLDP is enabled, LLDP MED is enabled, and the network policy is enabled. You may also want to enable extended power via MDI. This is recommended to always be enabled, as it allows negotiation of fine-grained power control and also allows Type 1 devices to negotiate 802.3 AT power levels on PoE. Enable LLDP VLAN assignment delay to define the amount of time to wait before allowing default VLAN access without LLDP exchange. Once the desired settings are chosen, save the profile. A service profile needs to be created for voice over IP services. To create a service profile, go to Profiles, Service. Select the icon to create a new profile. 802.1p marking mode should be set to static. Since only the phone is on this VLAN, we can statically mark all of the voice traffic with the desired priority. The priority is typically set to 5 in most installations. However, this should be governed by your local policy. The VLAN should be assigned to the one dedicated to the VoIP service. Tagged indicates that the traffic from the phone will be tagged on ingress with the specified VLAN. Class of service should be set to VBR. This will put the voice traffic on a separate traffic container on the PON. The VBR traffic container is serviced prior to UBR, so it will be given a higher priority on the PON. LLDP application type should be set to the application type of 1, which is voice. Once these parameters are set, save the profile. This profile will be assigned to the NAC profile. The LLDP profile and service profile need to be assigned to the line. In the ports application, select the service port and assign the NAC profile with the VoIP service profile and LLDP profile. Assign other Ethernet port profiles as needed and activate the port. The LLDP exchange can be viewed via the Ethernet port, protocol, link layer discovery on the status tab. In the status window, the network policy attribute and VLAN ID are shown. It also shows the results of the LLDP extended power via MDI attributes, which are used for fine-grained PoE power control. Many vendors' phones do not properly implement the LLDP interface, which can lead to issues with LLDP managed phones. This section will define some common issues seen and recommend ways to resolve these issues. Tellabs has done its best to put in workarounds where possible for phones incorrectly implementing LLDP. It is recommended that you always run at least feature package 27.1 or greater to get the benefit of these workarounds. The Cisco IP phones demonstrate the following boot up sequence. 1. Send DHCP request untagged. 2. Send IP version 6 router solicitation. 3. Send CDP. And 4. Send LLDP MED. If a port has both untagged and data VLAN and a tagged voice VLAN on the same port, this may result in the phone getting registered on the data VLAN. Since the LLDP MED is coming last, the Cisco IP phone may end up getting an IP on the data VLAN. If a route exists on the data VLAN back to the CUCM, then the phone may also get registered on the data VLAN. Tellabs ensures that reception of packets on the untagged VLAN will be suppressed until the LLDP TLV posture of the neighbor device has been confirmed to match the posture advertised by the OLT. This means that the DHCP and CDP messages will be suppressed on the untagged VLAN until it is determined what, if any, LLDP support is available on the neighbor device. To enable this behavior, the RSTP profile must have the admin adj port flag sent. To do this, go to Profiles, RSTP. Edit the RSTP profile to enable admin edge support. Then save the profile. During a software upgrade or reconfiguration of a profile, the OLT may revoke the LLDP MED network policy. When this happens, the IP phone can get stuck showing configuring IP and will no longer be operational. According to the specification, this should not cause an issue, but appears to cause a problem with some Cisco phones. If the phone goes into this state, it must be rebooted. As a workaround, phones can be rebooted remotely by changing the PoE profile of the phone to disable delivery of PoE, and then changing the profile back to deliver power. This will turn off all phones, then on with a single change. This concludes this video. In it, we have discussed an introduction to LLDP and its application to voice over IP, configuring network policy TLV to support voice VLAN, and an explanation of some common VoIP phone issues when using LLDP.